Good morning, ladies and gentlemen. Today's a video on MCR3U functions on exponential word problems. I think it's lesson 3. Hopefully from the handout you've actually got a chance to look at it. We're going to take a quick look at the peek of the formulas were provided. So hopefully, as you can see, we have 3 kind of formulas that we kind of recommend that you kind of know. Some people just kind of remember the last one, which is the general exponential function equation. Hopefully I can mark this up with a highlighter. So this one is the one that most students actually know, where y equals c times a to the x, where y is the new amount, c is the initial amount, and a is the growth factor or decay factor. Hopefully we'll talk about it in a moment with an example on the other screen, but this is the equation you have. And then we have actually, in my opinion, 2 derived equations, the exponential growth equation and the exponential decay equation. And notice they look very, very similar. Now, honestly, the variables don't really matter, the m or the c. The m stands for the new amount or total amount, and c stands for the initial amount. You might see me in other examples, so I use a different little c value. But take a look at the base. Notice in this case, for the growth, that a value is 2, where 2 stands for doubling, right? So that's clearly greater than 1. When we look at the exponential decay equation, notice the a value is 1/2. That is less than 1. Now, let me just zoom in really clearly because maybe some of you can see in your hand a bit more. The exponent that's affecting the base, in this case for the exponential growth, that 2 to the t divided by d. The t is the time allowed, and of course it's being divided by the doubling period. Whereas in the exponential decay, 1/2 to the t divided by h, again, t is the time period and h is the half-life. Time actually where the amount actually decays to half its original amount. So I think I'm going to do a few questions with you. I think I'm going to take a look at question 1, question 5, question 8. And I actually posted the old word problems. There's actually supposed to be 14 word problems, but that's okay. If you need more help, you can always look at the CEMC courseware material and get more problems there, or you can look online, just Google exponential word problems, and I'm sure you'll be able to find lots and lots of questions. But I think doing at least the first 10, you should be okay. So let's take a look at this first question. Question 1 says, a bacterial strain doubles its number every 5 minutes. Suppose there are 100 bacteria now. So write an equation to represent m, the number of bacteria t hours from now. And question B, how many bacteria will there be after 0.45 hours? A lot of students actually understand that this question is clearly a doubling problem. And I'm just having some tech difficulties. 1 second, please. And notice they want you to actually find the bacteria t hours from now. So a lot of students actually will probably do this off the side. The doubling period is 5 minutes. The initial amount is 100. And we don't know what the t hours are for now, but they wanted hours. So they have all the information here. And clearly, there's a problem with our units of time, 5 minutes and hours. So for question A, we first have to actually change that time period into hours. So let's just do it down here to the bottom. So 5 minutes, using our unit conversion, if you don't know, it's 1 hour for every 60 minutes. And the minutes divide up, right? And so what we're left with is a fraction of 1/12 of an hour. Now you could definitely use a decimal, but there's a reason why I'm going to use 1/12 of an hour. And so when we use the equation, m is equal to, because it is a doubling problem, c times 2 to the t divided by d. We sub in the values because we want to find what m is. And they just want an expression. 100 is the initial amount, 2. And then it's going to be t divided by the doubling period, which is 1/12. So recall right over here, when you do t divided by 1/12 as a fraction, ladies and gentlemen, It means you multiply by the reciprocal. So for question A, this is the answer that we're looking for. One more time. It says for question A, write an equation to represent M, the number of bacteria, T hours from now. So now that we have the equation, question B is really easy. Because for question B, we're going to let T equal 0.45 hours. So plugging this into the calculator, M is equal to 100 times 2 to the 12 times 0.45. And remember, you have to use order of operations. So some students think they do multiply 100 times 2. Remember, we have to do the exponent first, and then you do the base 2 to the exponent, and then multiply by 100. And hopefully you're doing this with me or pausing the video. You should get an answer on your calculator that gives you something like this. Now, this is a good math problem, but because the actual answer should be in bacteria, so we can't have a decimal bacteria, so the answer is actually rounded down for this word problem. 4,222 bacteria. So hopefully that wasn't jarring. That was another just making sure we got question 1 done. Okay, let's move to question 5. Question 5. In 1947, an investor bought Van Gogh's painting Irises for $84,000. In 1987, she sold it for $49 million. That's amazing. What annual rate of interest corresponds to her investment? So some students have difficulty with this particular question. And once we walk through it, you should be all right. Clearly, this is a generic exponential problem. And so we have that equation y equals, I think, mc to the a or ca to the x. I think something like that. Couple things here. We know the original amount is 84,000 for the painting. And the new amount, I'm gonna use m if that's okay. I think it's y in your formula, 49 million. Right, now the time frame that we have for the x value is from 1987 all the way to 1947. So this obviously represents 40 years. Sorry about that. We're getting some phone calls. 40 years. So how we would set this equation up, we have 49 million is equal to 84,000. The growth rate or decay rate, in this case it's the growth rate, because it grew from 84,000 to 49 million. So I think a lot of you understand it's growing. That's 8 to the 40. So once we set this one up, this question is very different from the warm-up question or the question 1 that we did, is because we need to solve for the base. And so when we're solving, one more time, we do reverse BEDMAS, and we divide each side by 84,000. So on the right-hand side, we do get a to the 40, but then the 49 million divided by 84,000, it's approximately 583.3 repeating. Now, you don't truncate this because it's not intermediate step, so don't do that. But some of you may or may not kind of know how to actually get the A all by itself. And so one more time, a lot of you understand if something was being squared, the opposite of it is square rooting. So in this case, what we're going to do, oops, I'll use red. We're going to take the 40th root on the right-hand side, but if we do the 40th root on the right-hand side, we have to do it also on the left-hand side. Now, just some of you might not know how to use this on your calculator. On your calculator, some of you, and I apologize, I unfortunately don't have the Sharp EL510 right now at home, but some of you might have the Y to the X button, and then above it, it might actually show something like this, right? So the way that you're going to enter this into your calculator, and I'll try to show this on the screen. Let's say this is the display of your calculator. You put the 40 in, and then you push this button, shift, of course, or second function. Some of you might have that button, and that's what's going to show in the display, right? And because I already did this question, when I do this, This is going to be A. And then what we're going to get is we're going to get the 40th root. And then you're going to get something that looks like this, 1.17259. Now, again, if you just use the answer key, it'll do the answer in there. So this is just going to display from your calculator. Now, some students still, it says, what is the annual rate of interest corresponding to your investment? So some students, again, we haven't really talked about the financial math, but if we subtract 100%, or the 1, subtracted by 1, and it keeps on going, right? So it's approximately, right? Then we're going to get 0.1725, which is a pretty good answer. 26, really. And so the growth rate, or the annual interest rate, is going to be, since it's a decimal, is 17.259%. Okay, so this question 5, is really checking to make sure you actually understand how to use your calculator and understand, our radicals, right? Our root functions. Our final question is question 8. Question 8 says, in 8 days, a certain amount of vanadium-48, that's an element, isotope actually, vanadium-48, decays to 1 over root 2 of its original amount. What is the half-life of vanadium-48? And again, because of the question, it's clearly a half-life problem. But again, some students find this difficult to do. They're saying, well, their new amount is 1 over root 2. What's the original amount? Well, you know what? Since we can deal with 100%, why not make the original amount 1, right? And then, of course, t is equal to 8 days. So how do we set this up? So using the equation, 1 over root 2, that's the m. The c is our 1, so we'll put 1 there. It's half-life problem, so we put the half there. And it's going to be, time is 8, so 8 over h. So we're solving for h, the half-life. Now, again, if you saw the previous supplementary video on logarithms, you can definitely use logarithms for this, but I don't think we really need to do it. And the reason why is because 1 over root 2 is actually equal to, as a base of 2, to the negative, y negative, because that's a fraction, and y half, because square root is a half, right? So remember, some of you know that this is the same as this. So that's on the left-hand side. How about the right-hand side? Well, the 1 we just ignore because 1 times anything is itself. And 1/2, we can rewrite that as 2 to the negative 1. And again, some of you already know this because of the exponent rule. A to the negative b is 1 over a to the b. And if you haven't been following along, well, hopefully you did your assignment. I like power rules a lot. So what I can do is multiply those exponents. So I'll just take an extra step. And if the bases are the same, we can equate their exponents. So we got negative half is equal to negative 8 over h. Get rid of the negatives. 1/2 is equal to 8 over h. And then, of course, h using cross multiply or rearranging, 16. Half-life of vanadium-48 is 16 days. And I guess I should have done the previous questions like that too. So annual interest rate. The first question, I think, did we do it? Yeah, I wrote a statement there. So hopefully that helped with the 3 questions. And some of them, you just got to puzzle them through, try your best. I don't really want to walk you through all of them because I think you can figure it out yourself. These questions are just geared to make sure you know how to rearrange. And then as always, you're more than welcome to email me at school. If you have any questions, feel free to refer to your textbook. look at the CEMC courseware. I wish you all the best. Hope everyone's okay. And there will be another digital assignment related to word problems. Have a nice day. Take care. Bye-bye.